Hi, Miss Marion here. We are doing Unit 4, Lesson 10. Go ahead and turn back to page 131. Read the I can statement. I can identify ordered pairs that are solutions to an equation. I can also interpret ordered pairs that are a solution to an equation. So 131 or 95, which one it actually shows us, okay? And give yourself a number. So 1, I don't remember. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. Our ultimate goal for today is to be able to determine in writing a point that satisfies two relationships through a graph or table. And we're going to interpret orally and in writing points that lie on one, both, or neither lines on a graph. And we're going to kind of talk about those and what they actually mean. All right, let's go ahead and turn to page 72 or 51, whatever one looks like this. And you are going to answer the question, which one doesn't belong? So you're going to fill in the sentence frame. You're going to write it underneath this picture. I believe that blank doesn't belong because blank. Go ahead and fill that in and then come back to me. All right, so we can go ahead and kind of fill this in. I believe that A doesn't belong because the lines do not cross. Or I believe that B doesn't belong because it only has 2 lines and the rest of them have 3. I believe that C doesn't belong because all 3 of the lines cross at one point. Or I believe that D doesn't belong because it does not cross at a point. However, what you think about is correct. We're just kind of getting our brains thinking for right now. So I have $2 in my pocket. What might be in my pocket as far as to make the $2? So let's just kind of think about it for a second. I can have dollars, right? I can have dollars I can have quarters. I can have dimes. And I can also have pennies, right? Now, can I have a $5 bill? No, because my total is $2, right? I can have a $2 bill, though. But anyway, I can have dollars, quarters, dimes, and pennies, and a mixture of those to be able to make the $2. So kind of keep that in mind when we go into the next activity. All right, here is page 73 of 52, however, which one looks like this for you. And it says, Jada told Noah that she has $2 worth of quarters and dimes. I'm going to underline that in a second. Okay, so we have quarters and dimes in her pocket and 17 coins total. She asked him to guess how many each of the type of coins she has. Okay, so here's a table that shows some combinations of quarters and dimes that are worth $2. Go ahead and complete the table. So go ahead and pause, complete the table, and then come back to me, okay? All right, so let's go ahead and look at the 4, and those are quarters. So if I remember that 4, so quarters are worth 25 cents, okay? So let's grab a calculator, do 0.25 times 4. How much is that? That is $1, right? And then let's see about it. I need $1 worth of dimes. And dimes are 10 cents. Okay, so how many of those do I need? I need 10. Okay, let's do 0 dimes. So 0 dimes times 0.10 is 0, right? That means I need $2 worth of quarters. And so if 4 makes $1, that means I need 8. Okay, moving on. We have 5 dimes. So I have 5 times 0.10 is 50 cents, right? And I need $1.50 in quarters. So 4 makes $1. And then I just need 50 cents more. Oh, that's going to make it 6. And then the bottom table is totally up to you as far as what you want to go ahead and fill it in. So I'm going to let you go ahead and fill that in yourself, okay? All right, let's look at number 2. You have this picture on page 73 through 74 or 52. And it says, here's a graph of the relationship between the number of quarters and the number of dimes when there are a total of 17 coins. What does point A represent, and how much money in dollars is the combination represented by that point? So go ahead and pause for a second and answer that question, and then come back to me, okay? All right, so let's kind of look at A. So A is this point right here, right? and that is 8, comma, 9, okay? And let's label the 8. 8 is the quarters, and 9 is the dimes. So if I had 8 quarters, how much would that be? So let's take 8, let's multiply it by 0.25, right? And so that means I'm going to have $2 in quarters. Okay? And then 9 dimes, let's take 9, and we'll times it by 0.10 because it's 10. And then I have 90 cents of dimes. And then how much do I have total? I have $2.90 of money total. All right, let's look at number 3. Is it possible for Gia to have 4 quarters and 13 dimes in her pocket? So let's kind of go through that. If I had 4 quarters, we're going to multiply that by 0.25, right? So 4 times 0.25, because it's worth 25 cents. That is $1, okay? And then we have 13 dimes, and dimes are 10 cents, so 13 times 0.1, that's $1.30 in dimes. So what do we have total? If we add that together, we're going to have $2.30 total for the amount of money. So can Jada have 4 quarters and 13 dimes? The answer is no. Guys, it makes $2.30. All right, so let's look at number 4. How many quarters and dimes must Jada have? Okay, so she has 17 coins total, and it needs to be up to $2. So go ahead and pause right now, answer this question, and then come back to me. All right, so did you figure it out? So Jada, she needs to have 2 quarters and 15 dimes. So let's kind of walk through that. So 2 quarters, so 2 times 25 is 50 cents. Okay, 15 times 0.15, or 15 times 10 cents, so it's 0.10. That is $1.50. If we add those together, does it make $2? Yes, it does. So Jada needs 2 quarters and 15 dimes. So notice how that is actually in the combination of different things. We have this point right here is 2, 15. So 2 quarters and 15 dimes. So that is an answer to the table that we actually did at the beginning, where we're putting in those combinations of different things. So it's $2, so a combination of 17 coins, right? But it has to be $2 total. So let's go ahead and let's turn to page 75 or 54. Let's look at a different activity, kind of looking at solutions on the line and lines itself. So Claire and Andre are making signs for all the lockers as part of the decorations for the upcoming Spirit Week. Yesterday, Andre made 15 signs and Claire made 5 signs. Today, they need to make more signs. Each person's progress today is shown in the coordinate plane. Based on these lines, mark the statements are true or false for each person. Before we go ahead and answer this, we need to figure out which line is which. Notice how Andre made 15 signs. So we need to figure out which line starts at 15. So if we notice, this point here is 15 because it goes 5, 10, 15, 20, 20, 30. So that is Andre's line. Then we need to figure out Claire's line. Claire started at 5 signs. This is 5, so this is Claire. Okay, so now that we know which lines are which, go through this table and answer the questions that are on this table and put it as true or false, and then come back. So pause and then come back to us. All right, so let's go ahead and let's look at A. At 40 minutes, I have 25 signs completed. So at 40, I'm going to put this in a different color. At 40, we have here. Do we have 25 signs completed for both? So Claire, so that's blue line. Yeah, that's true. Andre, that's black line. Okay, that's also true. Then at 75 minutes, so 75 is here and here. So does Claire have 42 signs? So is that true or false? Does Claire have 42 signs? So that's the blue line. Does she have 42? Yeah, it's a little bit above 40. So that is true. Does Andre have 42 signs? That's the black line. So if you look at it, go over, that's not. So his is false. At 0 minutes, I have 15 signs. So at 0, so Claire, is that true or false? That's false. She only has 5 signs, not 15. For Andre, that's that one there, right? Yeah, at the beginning, he had 15 signs. So for her, it is true. And then when at 100 minutes, I have completed 60 signs. So Claire is the blue line. Has she made 65 or 6D signs itself? Well, no, that's false. She only made 55. And then Andre, he's the blue line. At 100 minutes, he only made 40. Does he have 60? No, that is false. So notice how we can see if these things are true or false, or if they are a solution on the line or not for the different questions that we have. So this is kind of what we're looking at for today. We're looking at were these answers on the line, so were they solutions, were they answers on those lines, were those true or false? And so notice how A, yeah, it's on both the black and the blue line, but B is only on the blue line, and then D is also only on the blue line itself. So remember when it's a solution to a line? Well, we just kind of showed that with the tables. Yeah, these are solutions. They're really, really good. So on page 76 or 55, okay, we have this diagram. This is Are You Ready for More? We're going to go ahead and do it. And it says, do you see a pattern? If so, how many toothpicks would you need to make 10 squares according to your pattern? Can you represent the pattern with an expression? So kind of see what's going on and then use that pattern to go ahead and make 10 squares. So go ahead and pause right now and then come back to me. All right, so what do we see? So to be able to make a new square, so we start with what we have at first. So we're going to go 1, 2, 3. And to be able to make a new square, so this would be like the fourth, like 4 squares or fourth, I need 1, 2, 3 more toothpicks. So 3 more, right? 3 more toothpicks. Okay? So to make an equation for toothpicks, we're going to say toothpicks equals, we're going to start with that first toothpick. And then we're going to add 3 more toothpicks for every square. So we're going to say S equals squares. Okay? So let's try it. If we had, for 1 square, let's put 1 in there. So how many toothpicks do we have for 1 square? So there's 1, 2, 3, 4. So for 1 square, I can put it in there. I can say 1 plus 3 times S, or 3 times 1. 3 times 1 is 3, plus 1 is 4. Okay? Let's try it for 2 squares. So S equals 2. How many toothpicks will I need? We're going to do 3 times 2 is 6, plus 1 is 7. And we can kind of count them. So 1, 2, 3, 4, 5, 6, 7. Okay? So 10th. So squares, I need 10. Let's put it in there. 3 times 10 is 30, plus 1 is 31. So I will need 31 toothpicks to be able to make 3 squares in a row if I'm following that pattern. So just kind of make our brain kind of thinking about math for today. So today what we were doing is we were looking at tables, and we're finding an order pair is actually a solution to a table, but it's also a solution to a line. And then we can actually ask questions about that. So sometimes we need to look at things with graphs. Sometimes we need to go ahead and look at things through tables, but we can always answer questions to everything that we have and to be able to understand what's going on. So that was kind of our goal today. We have tables, graphs, and lines. We were figuring out if something was a solution to it or if it wasn't a solution. So go ahead and turn back to page 131 or 95. Read the I can statements, 2 of them. I can identify ordered pairs that are solutions to an equation. I can interpret ordered pairs that are solutions to an equation. And so we're looking at solutions, equations, and tables and graphs. Go ahead and write yourself a sentence about how you feel about it, and then give yourself a number. So 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So today we are doing practice problems 10. Make sure you get those and put the answers into Canvas. And I hope you have a good day. Thank you. Bye.